So we're going to begin with question 5. I turned the video off just so you can see more of the screen as I code. We mentioned wanting to be able to actually here on question 5, use the read table function in order to import data from an Excel file, use the dot notation in order to extract the relevant data, and then use the histogram in order to generate a plot of a variable that's contained within a table in an Excel file. How do you do that? I'm sorry, I started, to be honest with you, I started rambling. That's why I cut the video there. Sorry, it was a long weekend, pretty tired. But the way that I'm looking forward to break, like the rest of you. So what I'm going to ask you here, I'm going to give you an Excel file, and I'm going to basically say, write me a script in order to import it and actually plot a histogram of a particular variable. So remember that the way you do this is you need to pick a name for the table that will be used to store the data in the Excel sheet. So you can call it imported data, and I might tell you what to call it just to make it easier to grade. But the function that you need to use is the built-in function read table, and then say I just ask you to do it for your final project data, which I probably will, since most of you will already have that file stored in whatever your working directory is from MATLAB. But the read table function takes the name of the file in, and it actually extracts all that information into a table that will be stored in your MATLAB workspace. The way that you actually extract a variable from that is to pick the name of the variable that you want to store the extracted value, pick the name of your table, and then use the dot notation in order to pick which variable you want to extract. And I, of course, will tell you that in the actual exam. And then once you have that data actually stored as just an array of double values, you can pass that into the histogram function, and it will automatically bin your data and generate a relative frequency distribution. And you can label that if you want. I probably will ask you to label it, but this is, if you recall correctly, what this data is the actual consumption, electricity consumption in kilowatt hours for the school on the Lummi Nation. So basically what we're doing is we're counting how many days, this is the frequency of occurrence, that the total consumption in 15-minute increments, I should say, has this actual value. So this is like if you wanted to put an X label, maybe I'll give you the actual X labels that I want to put on, because this is getting to a question of whether or not you understand what that data set is versus can you actually use the X label and Y label functions, which is what I want to test. So the X labels here would be the 15-minute electricity consumption, and the Y label is just the frequency of occurrence. And you could actually put, and I will tell you what to put there, but the X label could be measured in kilowatt hours. So what that is telling you is that throughout that entire year, there were 682 times that the electricity consumption was within whatever range of bins we had there on the x-axis. So let's move on. And again, just to be clear, you won't be expected to actually come up with those label names. So question 6, be able to interpret the R-squared value, which the formal name is the coefficient of determination, when fitting model to a data via linear regression. Remember that what that quantity tells you is what percentage of the variation in the data is actually described by the model. So we looked at a couple different examples of this in lecture. For example, we actually fit force and displacement data for a spring in order to make an estimate of the spring constant. And if that R-squared value was near 100%, what it tells us is that underlying data, that bivariate data, the relationship between force and displacement, was well described by a linear model. However, I think I showed you in the lecture videos for that, if you were to crank up the degree of that model to like a quadratic or a cubic or a higher order polynomial, R-squared would actually improve. Eventually, it would actually become 100%. And what that would tell you is that that model can fit the data perfectly. So what I'm trying to emphasize by that last comment is having an R-squared of 100% isn't always a great thing. It could mean that you're actually overfitting the data, particularly if you know that the underlying kind of model of the data is less complicated. And this is an idea called Occam's razor. I was watching, I think it was the Elon Musk on Bill Maher interview over the weekend, and he used the term Occam's razor. So if any of you saw that, what that means is that the tendency to, if you can use a simpler model, to use it, because particularly in machine learning applications, when you use more complicated models, they may fit your training data better, but it may actually be just overfitting, and they won't generalize well. So know that R-squared value, the coefficient of determination, tells you what percentage of the variability in the data is described by the model, basically how good the model fits the data, and that better R-squared isn't always a great thing, because it could mean you're actually overfitting, particularly if you have some underlying physical insight as to what type of model should be used, which you do in the case of spring data, because you know that Hooke's law is linear. Beginning here at question 7, make sure you know your basic conditional control structures. For example, if I ask you a very basic question to use a for loop to print integer values between 1 and 5 in increasing order, remember that the syntax for for is you have the keyword for, you have your looping variable, which you can define within the loop in MATLAB. You use some type of indexing like colon notation in order to define the range that this loop value will take on. Here it's going from 1 to 5. Since I have no middle value, it's going in increments of 1. Remember that when I actually just have a variable name and I don't have a semicolon, by default, that's equivalent to calling the display function. So what this will do is actually just print the values from 1 to 5 as I progress through the loop. And just showing you that here, I'll just paste it directly in. If you notice when this code ran, it displayed the values between 1 and 5. So make sure on the test that you know how to do that, maybe for like the even values between 1 and 10, just to show you if you were to, or the odd values maybe between 1 and 10. I'll do it for the odd values here, and then maybe you can do it for the even. But sorry about that. That's what I get for trying to actually paste it in. But if I were to go from 1 to 10 in increments of 2, let's see what this does. So if you notice in that case, it's starting at 1, but then in the next looping variable, since the looping variable index moves up by a factor of 2, it goes to 3, and then it goes to 5, and so on. So make sure on the test you know how to do that and modify it in order to print maybe the even numbers between 1 and 10. So think about what you would need to change in the code that I just showed you there. And I'm going to change this back before I actually post it. In addition, make sure you can do input validation. And just to keep the videos kind of shorter, where am I at time-wise? I'm at 7 minutes, so I'm going to cut this one, and I'll see you in the next video for beginning with the while loop.